Javier, are you ready?
Yes, I'm ready.
Thank you. Could you go ahead?
Okay, can you put it full screen, please? And yeah, is my voice tone okay? I'm not sure if I'm yelling at you or not.
I'm okay.
Okay, thank you. So, everybody, my name is Fabio Correa. I'm here at the Department of Anthropology here in College Park, and I'd like to share with you this exercise on public data sets from Harvest Choice with INLA. Next, please. So Harvest Choice is this initiative, this partnership between the International Food Policy Research Institute and the University of Minnesota. And its website says Harvest Choice generates knowledge products to help guide strategic investments to improve the well-being of poor people in the sub-Saharan Africa through more productive and profitable farming. And their products include geo-referenced data sets of different ecological and agricultural aspects of sub-Saharan Africa. Next, please. So I made this exercise because I actually do not have field data from my own research. These data sets that I got from this website available for all include 300,000 observations of 37 diverse variables. They include ecological variables such as carbon presence, presence of clay or rains, agricultural variables such as the length of the time of growth of crops, and these data sets include agricultural outcomes such as production and yields of different kinds of produce. For example, maize, which is what I selected here today. Oh, by the way, you guys. Please pardon my pronunciation, I'm not a native English speaker, sorry. The time range for some of these data sets, these time ranges are quite different. For example, the average rain data set, it is a 100 years interval. Other data sets are like just snapshots, very short intervals, such as the yield, for example, the yield. And some data sets actually include different integrated ranges, just a comparative study of different ranges, or in the case of carbon, different depths in which carbon was detected or calculated in soil. Next, please. So this analysis, I didn't want to go through the geo-reference way because we don't want to go. It is quite complicated with this kind of data set. So much information it has. I wanted to see if at least I could make a study of pseudo replication, just as we did in class. I also made an exercise in selection of variables, and an exercise in selection of models and comparison among models. Next, please. Okay, so for example, here are the spatial variables. There's just X and Y and a cell identifier, and it's just to give everybody a sense of the extent of this data. So as the website says, this is sub-Saharan Africa, and you guys can see it in the correlation plot of X and Y. These are 5-minute arch areas, and this data is all segregated across all these regions. So it's, as you can see, it's a very diverse data set, as you can expect. The ecological data and the agricultural data, it is all, it contains all kinds of information about all these spaces. Next, please. Okay, so in trying to go as simple as possible at first, trying, this is like how a preliminary model should work, particularly with this much data. We have this, for example, this is figure 9 from my report. This figure 9 is a comparison among the response variable I selected among the several candidates. It is the yield of maize, the yield of corn per hectare, which is an over-dispersed distributed data set. And the next one is SOC. This is the soil organic carbon content at 0 to 5 centimeter depth. This was also subject to a separate process of selection variables, which I'm not showing to you guys for the sake of brevity. But all these, maybe you can expect that all of these readings of carbon are correlated across the different depths in which they were measured. The next one is the length of growth of these crops, and the next one is a precipitation rate. So you can see that in these variables there are correlations, which is also something to be expected, and you can also see that these variables are all dispersed all over the place, because this data integrates information from many different kinds of soils and across nations. So it is a lot of information to consider. Next, please. Okay. Once again, these are the the example variables. Sorry, some of the variables that were considered for this study was. I tried to remove most of them after looking at their correlations among them. I just wanted to mention too that most the numerical variables were standardized, because being so many diverse factors, so many diverse measurements that we have, having the bare measurement is not as informative. Maybe a better information, we can get better information by standardizing these variables in such a way that the coefficients in the regression study will give us their relative contributions. So this is what we have with these standardized variables here, and the other variables, most of them were zero inflated, which is something that we saw about last week. So most of these variables were converted to presence or absence data. And the distribution that I used for the response variable was negative binomial. And okay, I think that's it. Next, please. Okay, interactions are something that needs to be considered in this model. I think in this analysis, in this preliminary analysis, the contributions of the variables without interactions will not be as important as their interactions. So just for an example of it, this is the interaction plot between the country factor variable and the class or the agricultural class or the agricultural classification factor. I'm really sorry that with this resolution it cannot be seen so clearly, but actually interactions between these two variables are observed here. These are the only two factors. Yes?
Fabio, I don't forget to mention the presentation is roughly 10 minutes.
Yeah.
It's already beyond that. So, and for everybody, please.
Okay, so let's just move this next. Okay, the thing that I would like to mention everybody is that actually INLA was very requiring regarding memory and processing power. I wasn't able to incorporate random effects, which is something I really would like to have, and what I was able to find here in these data sets is that the standardized ecological predictors such as rain and carbon contents are actually factors that influence the outcome less than categorical variables such as country or presence of clay or the agricultural classification. So I was also able to, I wasn't able to incorporate random effects, but I was able to incorporate interactions. By incorporating them, the deviance information criteria and the log likelihood actually varied less than 1%. So it was a lot of investment in computational power, but actually I wasn't able to distinguish an improvement of the model. If we go to the next, please. Okay, this is the last one. I just wanted to mention that the residuals actually improved despite what I observed in the information criteria. The residuals actually look a little closer to zero once we integrate the interactions between them, between most of these variables. You guys can see that there's a part of the data set that is separate from these residuals. I wasn't able to identify which factors contributed to that. But I would say that besides the information criteria and the log likelihood, looking at the plots of residuals is always useful. Okay, so that's the time I have. Thank you very much for your attention.
Thank you, Fabio. Due to time, we have to go to Cami.